That definitely was not Tony Rice. Lenny Kravitz said, "Are you going my way?" Is that it? Are you going my way? Yeah, going my way. Ernie's doing the camera work today and provided that selection. I've returned the exam this morning, and we're going to talk about it this morning. So we're going to spend some time talking about the exam, some of the things that was very clear after going back through. I did the initial grading and then looked at my distributions and decided that I had to curve it upwards, so I did. The top grade now is 96. And looking at the distribution, it's centered in the 70s. And overall, I'm reasonably satisfied now. But as we talk about this, let's see what kinds of things should have been done, places where there were little glitches here and there. So let's go to the first problem on the test. We go to the document, Ken. I gave you the slope at -5.6, and I gave you an intercept at 0.3, and the place where we didn't do what I wanted was when I asked you to put the answer in standard form. So the question, as we come off there, what do we mean by standard form? What form does the equation have to have? AX plus BY equals C would be standard form. So with that in mind, the first thing we would do is just go to the slope-intercept and make that as our first step. But then you want it in standard form. So essentially you're going to multiply everything by, well, there's two ways you can do this. And technically I didn't think about this until after the fact. And if you have it written as 5/6x plus y equals 3, and I took anything off, I owe you something. But the idea was, as I slide over, multiply everything through by 6 to get rid of the fraction, and 5x plus 6y equals 18 was what I wanted in the final solution. So the idea was to have a standard form. One more time on that, Ernie. People were still writing. 5x plus 6y equals 18. That's standard form. Okay. Now, the next one. We're going to have you doing a lot of buttons today, Ernie. So we have, this is the equation, 2/3 x plus 1. Now I want the graph of that. So the intercept, as you look at it, is at 1, meaning 0, 1. And the slope at 2/3 means go over 3 and up 2. So as we come off that, you're going to have to locate the ordered pair 0, 1. That's what I've done here. And then going over 3 and up 2. Now I didn't indicate for you in this particular ordered pair what it would be, but that would be 3, 3 for your ordered pair. But once you've done that, then it's just a matter of going ahead and drawing the graph. Now the next one. This is one of the more involved ones. I gave you this ordered pair, two ordered pairs, -2, 5, and 3, 1. Now point 1, we will consider the -2, 5. That is, this one right here I'm pointing to is the first point because it is to the left of the second. So point 1, point 2. First thing we need to do from there is to find the slope. Now there's my formula for the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I get a slope of -4 over 5. Okay, so that's just a matter of substitution. Then, as we come off there, the next thing is to go to the point slope form for your equation, which I have now. Y minus 5 equals -4 over 5 times x minus a -2. Now I was using the ordered pair negative 2, 5. I just did y minus y sub 1 equals m times x minus x sub 1. So as we come off there for a moment, the equation we're using, I'm writing it out, and I'll put it back under the camera. This is the equation we're using, and that was my substitution. So y minus y sub 1 equals m times the quantity x minus x sub 1. And I used the ordered pair negative 2 comma 5. So the first thing you had to be careful about was right here getting a negative and negative 2, which became x plus 2. Now the question is, as you simplify that, what should you get? Now, the first part, coming back to the camera now, and multiplying all that through, I get 5y. Now, I multiplied everything by 5. Get rid of the fraction. I have 5y minus 25 equals negative 4x minus 18, or 4x plus 5y equals 17. Or, coming off there, you could write it in this form. Minus 4/5 x plus 17 over 5. You had a choice either way there, but you had to simplify it in one of the other forms. Now the next question. We had an inequality. So we come back now to the next problem. 3x minus 4y greater than 12. I'm going to show this one on the board because we need to have a little more practice with this one. For some reason, the single inequality caused troubles. So let me write the equation or the inequality first. 3x minus 4y greater than 12. Okay, as we come to the board now on that, we're going to have to draw a graph. But before I do that, I'd like to go ahead and get some ordered pairs for the line. So I'm going to let x be 0. And then I'm also going to let y equal 0. And this is a place where we're still having a little bit of trouble with this. If x is 0, then y would have to equal what? Negative 3 as an equation. And if y is 0, x is 4. So we're going to go ahead and graph. When I do that, x, my, reminder, this is an inequality, so once I get my line determined, then I want to ask which side of that line I'm on. So I need to have a scale here. Let's see if I can get that. Done. 4, 0. There's 1 point. And at 0 minus 3, I have the other point. So these are the 2 points, this one and this one. And I'm going to join those with a dashed line. Why dashed?
What's
the argument? It's an inequality because I had greater in it, not equal. Now the next step, I need a test point. My test point will be
0, 0.
0, 0. So I test the point 0, 0. And I ask, does that point satisfy the inequality? Well, if I have a 0 for y and a 0 for x, that's going to give me 0. Is that greater than 12? And the answer is no. So this point right here didn't work. So my test point was right there. It didn't work. And so I'm arguing everything on that side will not work. And so my solution is everything what you might think of as below that line. And that's what should have been done for that problem. Now one of the things that really frustrated me, I had a lot of people draw the line, dash the line, and not give me the region. And so that was like 3 points that you'd lose for not determining the region involved. Okay. Get this up just a little bit higher. There we go. In this problem, as we come back to the test, what is meant by a function? And then you want to give me a graph that is not a function. So as we come off that, okay, I have a not a function. Now this is not a very neat looking graph. It was sketched without straight edge or anything. Let me slide that over. That's to, let's see, about there. Okay. That's not a function. Now, with that as a statement, why is it a function? Why is it not a function? Rephrase that more carefully. A vertical line does what? Cuts that graph in two places. So as we come off there, the question, what then is a function? A set of ordered pairs. That's one of the things I wanted you to say. A set of ordered pairs. And for every x, there's what?
One y.
Just one y. Now, some of you argued that for every y, there could only be what?
1x.
1x. Let me ask you to think about this graph. Y equals 3. Horizontal line. For every x, there's only one y. But every pair has a 3 in it. 2, 3, 4, 3, 5, 3, 6, 3, 7, 3, 2.5, 3. The problem is a single x can't have two y's. But a single y could have a whole lot of x's related to it, as in a horizontal line. You could have drawn a circle for your example of not a function. Okay, let's go to the next one. Here is a system, and I ask you to solve this system doing what? Using a graph. So as a graph, I didn't expect you to do substitution. I didn't expect you to do elimination. I wanted you to draw the lines. So as we come off there, this, again, isn't the most elegant looking graph in the world, but it illustrates. You have two lines, and I was just freehanding this with a fountain pen. It's awfully hard to use a straight edge. But even there, looking at these two lines, they do meet at 3, 2. And those were the two different lines involved. That's what you should have done. The first line, I'm not sure how we define the first and the second, but if I think of 2x minus y equals 4, then when x is, let's see, if x is 0, y is minus 4. And so we have this point right down here. Then when x is, let's see, 2, y is 0. There's my other point. So that was that first line, this one going up and down this way. The other line, the second equation in the system, had an ordered pair of 0, 4, and what turns out to be what? 1, 2, 3, 4, 5, 6, 0. And getting those two lines then drawn, they meet at the common point 3, 2. And all you're expected to do here is figure out how far over. We went over 3 and up 2 to get to that point. So that's all you had to do as we come off there. Now the next one, substitution. Okay? The problem was set up for you so that substitution worked pretty well. Y is equal to 2x plus 6. That's what's done in that one. So y equals 2x plus 6. And then we're going to put that in the first equation. So that's the idea as we come off there. And I will show you the substitution that I went through here in just a moment. Okay. y equals 2x plus 6. Then I had 5x in the second equation plus 2 times y. And all I've done is substitute 2x plus 6 for that, and that's to equal negative 15. Now when you simplify that, let's come off there for just a minute, Ernie, and let me get this set up so we can see what happened. Here is the calculations I sketched in. I have 9x plus 12 equal to negative 15. And some of you got a little bit careless with your minus signs. If I add negative 12 to both sides, I end up with 9x equals negative 27, as you can see in the screen. X then is equal to minus 3. So while we have that right there on the screen, if I look right next to my 3 and think of 2x, 2x would give me minus 6. The right side's minus 6, so y has to be 0. So that gives me negative 3, 0 for my solution set, and that was the answer in that problem. Well, the next one, I ask you to do elimination. 2x plus 3y equals 21. 5x minus 2y equals negative 14. Now, you had two choices. I preferred myself to multiply the first equation times 2, the second equation by 3. Didn't have to change any signs then. Then if I add, the y's will disappear. I've eliminated them, and I'm going to have something in x. So coming off that as a statement, let's see what happens when you do that. So as we look at the problem, you can see what happens as I multiply the first equation by 2. The second, now hold, let's see what I do here. I need to slide up a ways. I'm trying to think what I did there. This was 2x plus 3y. So I multiplied the first one by 2 and the second one by 3. And that's what you're looking at. Then when you add, 19x is 0. X equals 0. And if we think of coming back, let's come off there for just a moment and come back to the original system. If x is 0, and I go to that first equation, if x is 0, 3y is 21, y is 7. So I have 0, 7 for my solution. Then we get to a system of inequalities. Okay, here's my inequalities. Now the first thing we had to do is note that the first line is solid because it has a less than or equal. The second line has to be dashed because it is less than. So these signs right here, the less than or equal tells me solid line, the less than tells me a dashed line. I tried to set this up nicely for you so that your intercepts were easy. If x is 0, y is 3. If y is 0, x is 2 in that first one. And the second one was also to be rather easily done. This is what it, oh, let's see, I still need to see if I can get that centered a little bit better. There's my graph. It leaves something to be desired. Okay, but I have my two lines. One of them's dashed, one of them's solid, and I used the origin as my test point in each case, and the origin was in each, or satisfied each inequality. So we have this region right here, which was in common to both. That looks a little bit like a modernistic art form. Just think of your wallpaper looking like that. A whole room with that as a graph. Okay, coming off there. Now, Ernie, there's a new idea for your kitchen. Yeah. Graphs, right? You were wanting a nice new wallpaper. Okay, that one shouldn't have been too bad, and it went pretty well. The next one, we want some distance between 2 points. This was a A little bit of a disappointment for me. So let's talk about this. First, I need to write the ordered pairs. Now, this was -3, 4, and 2, 7. So the argument, if I want the distance between 2 points, there's a formula I'm supposed to use. And clearly, we did not do enough of these.
And I did the review exercises and the test, and the chapter test, and it didn't cover this. So I completely forgot about
Chapter
it.
test didn't cover it. Okay, because we did this as a problem. We talked about it. It's x sub 2 minus x sub 1. By the way, this is one of the reasons I gave some points back, because it was clear this did not get studied as well as I'd hoped. This is your formula. Now, it's based on the Pythagorean theorem. So let me draw the diagram again that's involved here. Now, the argument is I'm going to have 2 points. That's like x1, comma y1. We technically should say x sub 1 and y sub 1. And up here another point which I'm going to call x sub 2, comma y sub 2. And then what we do is join these together. I want this distance. But what I'm going to observe is that there's a right triangle involved here. Now remember, to get to x1, y1, I went over to x1. That's what this is. And to get over to x2, y2, I went over here to x2. So the distance of this leg is x sub 2 minus x sub 1. And in the same way, this shorter leg is just y sub 2 minus y sub 1. So this base of the triangle is x sub 2 minus x sub 1. And this height of the triangle can be thought of as y sub 2 minus y sub 1. And it'd be nice if I got the minus sign in between there. So minus y sub 1. The diagonal right here is the distance between. So using the Pythagorean theorem, it says that the base squared plus the height squared must be the diagonal squared. So we are saying d squared is equal to the base squared plus the height squared. Well, I have both base and height indicated there. So that's where I get d is x sub 2 minus x sub 1. That's your base squared. Here's your height squared. So what you needed to do was substitute into this formula. So if I substitute into the formula, I'm going to have x sub 2 minus x sub 1. X sub 2 is a 2 minus x sub 1, which is negative 3. Square that. Then plus y sub 2, which is 7, minus y sub 1, which is 4, and square that. So this is going to be the square root of what? 5 squared, which is 25,
Plus 9.
plus 3 squared, which is 9, which is the square root of 34. And that was your number. Just under 6. Square root of 36 is 6. So this is at 34, so it's just going to be a little bit under 6. Okay, let's come back to the document camera. That was the one problem that I think just didn't work. I had 1 or 2 people get it, but for the most part it was a disaster. So coming off that. Page 2. We're going on a boat ride. Okay, so here's our boat. You go on a boat ride and it takes 3 hours to go 36 miles downstream And what? If I slide over, 12 to go upstream. Now what you're wanting to know is the rate of the current and how fast will your boat go when you're in still water. Well, as we look at this one, first thing, you need to know what x and y are going to equal. X can be the speed of the boat, y the speed of the current. You have choices there. I did it in this way. So I said, as we come back to the problem, x is the speed of the boat, y is the speed of the current, and those are my two equations. 3 times x plus y is 36. 12 times x minus y equals 36. Okay? Now what I did, I divided in the first equation by 3 and got x plus y equals 12. And then x minus y equals 3. And add them together. Okay, and that gave me 2x is equal to 15, x is 7.5, and I was done. So looking at that again, divide the first equation left and right side by 3. So what I did was take this equation, divide by 3, so x plus y is 12. Then this one becomes x minus y is 3. Add them together, you get 15 here, 2x here, so x is 7 halves, 7.5, and you're done. Doing that, the current, by the way, comes out at 4.5. That was not one of the better problems. We did not do very well on a word problem. But that happens sometimes, so unfortunately.
7.
Okay, here's the next one, number 12. You were to simplify this. Now, I gave you a third root, cube root. What you should have seen in the 250 is a 125. And the 64 is 4 to the third. So you know you can have a 4 pulled out from the denominator. The numerator, 2 times 125, I can pull out the 5. The x to the 5th can be written as x cubed times x squared. So, coming off that for a moment, this is what it looks like with what you have left. 5x over 4, the cube root of 2x squared. That one was so-so. Okay, that was another one of the problems that resulted in not being able to give, well, in the points coming out where I wanted them. Okay, let's go to the next one. 75x squared plus x times the square root of 48. Now, a lot of you saw the 48 as 6 times 8. But that's not what you wanted to see. You were hunting for perfect squares. So 75 as 25 times 3. If you saw the 3 there as 25 times 3 right here, then you should see a 3 in this one if you have any hope. And 16 times 3 works. So as we think of that problem, as we come off there and come back to the solution, this is what you end up with as 5x the square root of 3, 4x the square root of 3, add them together, 9x the square root of 3 as I slide that over. And that would be your solution. Okay. Now, by the way, that wasn't 9 times the square root of 3. That was 9x the square root of 3. Okay, this one, I tried really hard to give you a nice problem, and you did not go for it. A 63 and 14. There's a 7 in each of those that I wanted you to do. 7 into 14 is 2. 7 into 63 is 9. And suddenly, life is good. Because you have a 9 and the square root of 9 is 3. Your x to the 5th can be written as x to the 4th times x to the 1st. So as we come off that, this problem we're going to do, let's put that one back up on the document cam. Let me write that on the board because this one should have been a lot easier than you made it. Okay, so let's see where I was trying to be nice to you. Okay, what I had in mind here was to say 7 into there is 9, 7 into there is 2. Now if you saw that, things got pretty nice because this is x to the 4th and the square root of x to the 4th is x squared. So you have 3x squared, the square root of x over the square root of 2y. Now that's the first step. Now that's not simplified because you have what? A square root in the denominator. What do you do when you have a square root in the denominator? Rationalize. Multiply by the square root of 2y. Now the square root of 2y times the square root of 2y?
2y.
2y. So I end up with 3x squared, the square root of 2xy over 2y. Done. Now that was supposed to be a problem that you would enjoy. It did not work like that. Back to the document cam for a moment, Ernie. That's the problem that was there, and that's the problem that wasn't. I feel like that was the week that was, and that was the week that wasn't. This is the problem that wasn't. It didn't work out real well. Okay, a new one to enjoy. The product of binomials, where you have 4 the square root of 5 minus 2, 2 the square root of 5 minus 5. FOIL. First, outers, inners, last. That's what we want here. Now again, the first times each. 2 the square root of 5, 4 the square root of 5. 4 times 2 is? 8. The square root of 5 times the square root of 5?
5.
5. 5 times 8?
40.
That's a big 40. Okay. Then what do we have? We have minus 4 the square root of 5 and a minus 20 the square root of 5. That's minus 24 the square root of 5. And what? This is, some of you just couldn't get that plus sign there. Minus 2 times minus 5 is
Plus
positive 10. We had 40. Add 10. 50. Minus 24 the square root of 5. That should have been this result right here. 50 minus 24 the square root of 5. Now that wasn't intended to be as bad as some of you, I think, made it, I think, partly panic. Let's come back to this question. This is another one that I think we need to look at. Ernie, we're going to have to take camera 2 over to the side. So we'll leave that on the screen for a moment and bring camera 2 over to the side. Ernie was getting by too little. He just had to press buttons. Now we get to moving cameras around, right? Got to get you reintroduced to all these controls again. The square root of 5 plus 4 and over a denominator of 2 minus the square root of 3. Now, question. You have to rationalize the denominator. Remember the conjugate. So I want the conjugate here. And that is 2 plus the square root of 3. Some of you kept it as 2 minus. Of course, what you do there must be done where? In the numerator also. Okay, now, the next one that was a little bit frustrating. You took 2 times 2 and got 2. I know you're thinking the square root of 3 times the square root of 3 is 3, so that's cool, then 2 times 2 is 2. What should this be in the denominator? 4 minus 3, also known as a 1. And it works so nicely. Okay? But the numerator is another story. Because we have to do what? Boil that. So what do we get here? I have the square root of 5 times 2, so that's 2 to the square root of 5. Then I'm going to take care of the outers. Square root of 5 times the square root of 3, the square root of 15. Then the inners, which is an 8. And then the last, which is 4, the square root of 3, and it's all over 1, so what I have at the top of the screen is your answer. Now, two things bothered me in this problem. So many of you did not multiply by the conjugate. Now, that's something that I think may have just been a matter of not focusing on this type of problem enough. And then the one that was a little more of a frustration was trying to get the 4 minus 3 instead of 2 minus 3. So many of you had a minus 1 there. And I think as you look at it now, you're probably chuckling and saying, I don't know why I did it. And I hope it seems as silly now as it seems. Back to the document, Cam, if you would please, Ernie. So we have the square root of 5 plus 4, and we have 2 minus the square root of 3 in the denominator. We used a conjugate. So as we come off there, I tried to give you a nice radical equation. That was supposed to be my gift. However, it didn't work quite that way as we come off that. Here was the first step and the solution. Subtract 1 from both sides. The square root of x is 2, x is 4, done. End of story, 10 seconds. Now, I would appreciate it if you checked your solution. That didn't necessarily happen. What about the next one? 8 to the minus 2/5 over 8 to the 1/5 times 8 to the minus 4/5. This we had just done, and I was surprised where some of us lost it in this one, because this should have been a case where without too much preparation, this one should have gone pretty well. So we had an 8 to the 1/5, and what's interesting, you did the right things. You just lost your cool with the fraction. So let's come to the board now. So we have 8 to the minus 2/5, 8 to the 1/5, 8 to the 4/5. Yes? Minus 4/5. Thank you, Ernie. Appreciate that. Okay, 8 to the minus 4/5. And I have 8 to the minus 2/5. Then what do I do down here? I could multiply these two together if I'd like. So that would be 8 to the what? 1/5 plus negative 4/5. So that's going to simplify to 8 to the minus 2/5 over 8 to the minus 3/5. Now you could just subtract exponents at that point, because this is a division. So have 8 to the minus 2 over 5 minus a negative 3/5. So that is 8 to the 1/5. Okay, that was my hope. And some of you, I think, just because we had those silly fractions in there, lost some points that you shouldn't have lost. Because I didn't feel there was a matter of not knowing what to do here. It was just getting trapped in some of those simple little things that happen. Let's go back to the document camera now. That was that problem, which is intent to work with some of the things we had just done. And then as we come off there, I said, take your choice. Have fun. There's the system. And the idea was to use any technique you wanted. And depending on what you did, It either worked better or worse, I guess, depending on how you look at it. I took the second equation and rewrote that as 3x plus 2y equals negative 5. So let me rewrite the system on the sideboard again. So I had 12x plus 8y equals 20. And then I'm going to rewrite before we go off the screen. I'll rewrite it. Okay, now I'll hold it. It would help if I did something in my head while I was wanting to do part of the solution. Negative 5. Okay, here we go. There's rewriting it. I decided to multiply the bottom one by negative 4. Okay? So my system at the top is still 12x plus 8y equals 20. Then I multiplied the bottom equation, left and right side, by negative 4. So, negative 12x minus 8y, and some of you just didn't want to do this. It is a 20, not a negative 20. Now when I add on the left side to eliminate x, I also eliminate y. And I get 0 equals what? 40. But what does that tell you? That you've got a contradiction. You started out with the idea that you're going to have a what? A solution. And you get a contradiction. So what does that do to your assumption? Negates it. Therefore, no solution. What kinds of lines were these?
Parallel?
Parallel lines. What kind of system? Inconsistent. Because the system was inconsistent with my assumption that there was a solution that was simultaneous. Back to the document, Cam, if you would, please. Okay, so that one was intended to introduce something else. And then I regret this. This did not work. I told you I'd try to maybe do one of these in the test as we come back. Two radicals, and this is one of the reasons why I ended up having to add some points back in. This was a two radical, isolate a radical, and then some people did the first step very well. So let me write the system, or not the system, but the equation. I have 2x plus 2, and then I have minus the square root of x, and that's equal to 1. Now, first step is to do what as we come to the board?
Isolate one of the radicals.
Isolate one of them. Well, I'll just take the first one and isolate it. The other one then goes on the right side, and I have 1 plus the square root of x. Then what must I do?
Square both sides.
Square both sides. So far, things were going well. The left side, we're doing well on that. You got 2x plus 2. And this is where we lost it. We forgot the middle term. Because this is 1 plus 2 the square root of x plus x. Okay? So that gave me x plus 1 equals 2 the square root of x. Okay. Then what do I do? Square both sides again. So I square both sides. On the left side, again, you can't omit the middle term. The middle term was lost a couple times for some of you. The right side. 2 times 2 is the 4, so the 4x. Now I have a second degree equation, which is an earlier set of material. So I went ahead and set everything equal to 0. And then I factor. And then I set the factors equal to 0, and that tells me that x equals 1. Now let's go back up here and check. Okay. X equals 1. I have 2 times 1 plus 2, that's 4. Square root of 4 is 2. So 2 minus the square root of 1, which is 1, is 2 minus 1, 1. Yes, it worked. We're done. Now, I knew that that was the last problem, and I knew that one might not go well. I just hadn't planned on a couple others not going well. So on this test, the 3 problems I did not pick well. Number 10. Number 20. Interestingly, the last one on each page. Now, which other one did not go well of the groups? Probably the one that went least well was the one with the cube root. Which problem was that? That had the cube root of 250?
Oh, 12.
Number 12? If these 3 problems did not go well, I understand why the 20th did not go well. The 10th, as Pam has commented, was not reviewed in the chapter test adequately. So that means 2 of them I understand. Number 12, nah, that one you're going to have to buy. But nevertheless, I did have to curb this 15 points to get my grades up where I wanted them. So the test on my part was not a roaring success the way I wrote it. But it worked out reasonably well in terms of what you did. So let's go back to the document cam one more time. That was that last problem. And overall, I can't say I'm particularly disappointed in the outcomes of the test, because the test was not easy. I asked Sarah, when I asked her to read the test, I said, well, is it maybe easier than she should be? And she sort of looked at me, said, no, it's not too easy. Which translates means it was hard. And I think it came out a bit harder than I was hoping would be for you. I had really hoped that that last problem you were ready for, and that you'd walk in water for me. You did good. You just didn't walk in water. But we'll go with that for the moment. Now the question, how does this test and the other 2 factor into your final? 30 questions, right? No, not 30. 60?
60.
20 in each? 20 in each. Plus, we had what, 20 something in the first one?
5.
So you have 60-some problems that we've done. Now we have a 2-hour final. Now part of the final is going to be on the new material, Chapter 10. And I think it's safe to say about 5 questions, at least, from that new material. And we have a test that should be somewhere around 30 to 40 questions long for 2 hours. So let's consider just 30 as a rough estimate, so that time isn't a problem. And you have 5 new questions to 10 new questions. I can take at least 20 questions out of the 65 you've had. So how might you want to prepare for the final? Study the tests. Now that doesn't mean look at them again. It means go back and what?
Do them.
Redo all the problems. So your homework for tonight. You have 65 problems on 3 exams. Redo them. Give yourself 3 hours. Question?
From the 20, you changed the sign
Yeah.
on the test to a
plus. No, not on this one. Not on the 20.
Yeah, on mine it's a plus. Ooh. You changed that one.
You have plus the square root of x
Yeah.
on yours?
Uh-huh.
Okay. Is it 5 plus 2y and the one above it?
No. It's 5 minus 2y.
Okay, because it was supposed to be 5 plus 2y and the one above it, and
You changed the wrong one for me?
no, I had asked, well, I'm trying to think, depends when you came in. I'll have to look, because maybe it was a matter, I tried to change some of those. I had walked around and then changed it at your desk, and I'm hoping I didn't screw that up, but it appears I did. So let me look at what you had, and I'll talk about it after class. But in terms of homework, what I'd like you to do is to go ahead and please spend your time for homework tonight, going back through the exams, and just do the problems again. That's a good preparation for the final coming up. Then tomorrow, we'll go ahead and start Chapter 10, and we'll spend the week on it. Try to get that out of the way, maybe into early part of next week as we finish that up. And then we'll review, and one of the reviews we will do is go back and answer questions on the test that you've been doing, trying to make sure that that will work. So with that, Ernie, we started with Lenny Kravitz, I assume. Is that what we're going to stay with? No, you're going to switch on me. What did you switch to?
Queen, A Kind of Magic.
Okay, Latifah?
Queen.
Queen.
Queen. Freddie Mercury.
Okay, and the title of the cut?
A Kind of Magic.
A Kind of Magic. That must be what algebra is, right?
Yeah.
A Kind of Magic.
Yeah.
Okay.
Yeah.
With that, have a great day.